Hi, welcome to another video. In this particular video, we're going to look at how to use LU decomposition to solve another system of linear equations. So let's just get right into it. Okay, so first of all, what was LU decomposition? So we said that, say we have a system AX equal to B. All we want to do is to decompose A into L times U, where U is upper triangular matrix and L is what? Lower triangular matrix. Okay, so once we have this, then we can have a two-step solution to finding the solution to this system. Okay, so let's see, what is our A here? Our A is basically 1 minus 1, 2, 2, 2, 1, 0, and then we have 0, 4, 2. So x1, x2, x3 equal to 2, 1, 1. So this is what we have. Okay, now this is our A, right? And we want to decompose this. Now we said how we're going to do that is, so let's start from here. We're going to use row reduced echelon metrics to do this. Right? And we can have our L here. Always the diagonals of our L will be 1, 1, right? Because it's lower triangular matrix, so we expect all the other entries above to be 0. So we just need to fill this part in, the lower part. And what's going to help us is the elementary row operations that we use, that we apply to this matrix, that will help us to determine those values. Now let's look into that. So the first thing is we're going to use this first entry to make the second one 0, the second row 0. So we're going to use that to make this 0. Okay. So how do we do that? So it's very easy. It's 2R1 plus what? R2. Okay. So minus 2R1 plus what? R2. That's what we're going to do. So what does that give us? So that would give us what? Which matrix? 1 minus 1, 2. This will give us 0 here, and this would give us minus 2 times minus 1, that is 2, 2 plus 1, that is 3, then minus 2 times 2 is minus 4, minus 4 plus 0, that's minus 4, right? Now, we don't need to do anything to this entry, right? Because it's already 0, right? So we said that since we are multiplying this with minus 2, to change this entry, we're going to do the same thing here. But we're going to take the opposite of that, which is the additive, not the reciprocal of this exactly, it's just the opposite sign, the same thing with the opposite sign. So instead of minus 2, it becomes plus 2 at that entry. Okay, now what's next? So now the next thing is, we are basically done with this R3 as well, because we think about it, that you were doing, is the same thing as saying OR1 plus R3, right? It doesn't make any difference, right? So basically, this place will still be 0. Right? Now, let's look at the next one. So this is the next entry that we have to change. We have to, we have to reduce, right? You have to eliminate that part to be 0. Now, in order to do that, we are going to use R2, which is what? So we're going to use minus 1 over 3. So the right one is minus 4 over 3 R2 plus R3. Now, how did I get this? So basically, think of it. I'm thinking of which number do I multiply to 3 to give me, to basically give me minus 4, right? Because if I have minus 4 and I add 4 to it, it will give me 0. So when I think about this, x will be what? Minus 4 over 3, as you can see. So that's how I figure out what should be here. Thinking of a number that I multiply to this, that will give me negative of what is here. Okay. So now let's compute this. This gives minus 1, 2, 0, 3 minus 4. So what do we have now? 0. So this is going to give us 0, right? So what we need to compute is this one. Minus 4 times minus 4 over 3 plus 2, plus this 2. Okay. So this would be 16 over 3 plus 2. And what's that? 16 plus 6, that's 22 over 3. So this will be 22 over 3. Okay, so this is what we have. Now, what have we used? We used minus 4 over 3. So that means here, we're going to have 4 over 3 in our L matrix, because we're just going to use the same number but with opposite sign. Now we are done. So this is basically our U, and that's our L. And that's how to decompose it. Remember, if you want to know whether this is correct, basically try this out. Multiply L and U together and see if it gives this initial matrix here, A. Check if this gives A. Okay, so now we're not going to do that. So we're just going to continue. Now that we have L and U, we're just going to continue to solve our equation. So the first thing is what? Remember, the first step is what? Ly is equal to B. This is what you need to solve first. So we have our L times Y, or we already know our Y, equal to B. What is B? This is 2, 1, minus 1. Don't forget. Now let's multiply this. That means 1 times Y1 plus 0 times Y2 plus 0 times Y3. So that is Y1 is equal to 2. The second one is what? 2Y1 plus Y2 is equal to 1. And the last equation is what? 4 over 3 Y2 plus Y3 is equal to minus 1. So we have Y1 is equal to 2. Substitute it here. That will give us 4 plus Y2 is equal to 1, which means Y2 is what? Minus 3. And finally, we substitute Y1 and Y2 here to obtain Y3, which is 4 over 3 Y2. So 4 over 3 times minus 3 plus Y1, which is, okay, plus Y3 equal to minus 1. Okay, good. So this gives us minus 4 plus Y3 equal to minus 1, which means Y3 is what? 4 minus 1, which is what? 3. So we have our Y1, Y2, and Y3 now. Cool. This is very cool. So now that we have this, we can use it to solve the second equation, which says Ux is equal to Y. Now notice that we need to find what our U is. We have our X, and what is our Y? Our Y is already given is 2, minus 3, and 3. Okay. Now we just need to figure out what our U is, which was here, which is 1, minus 1, 2, 0, 3, minus 4, and then 0, 0, 22 over 3. Interesting. 22 over 3. Okay, good. All right, now that we have this, let's quickly solve this. So basically, we multiply things out. So the first equation becomes x1 times 1, x1 minus x2 plus 2x3, that will be equal to 2. So we need to solve this system simultaneously now. So the second one is 0 times x1, which is 0, then 3x2 minus 4x3 equal to minus 3. And finally, we have 22 over 3x3 equal to what? I think this one is easy now. We can easily find x3 as what? X3 will be what? 9 over 22, okay? And then we substitute this x3 into the next equation. So if we do that, what do we have? We have 3x2 minus 4 times 9 over 22 equal to minus 3. So, again, we had to do some tough maths here. So 4 times 9 is just 36 over 22 equal to minus 3. So that means your x2 is basically minus 3 plus 36 over 22. And then you divide by 3, right? That's how you solve this. And if you do that correctly, that should give you minus 5 over 11. Okay. So I'm not going to do that, so you can just figure this thing out, right? Okay. So what's next is the third one. So is to solve the next equation, which is x1 minus x2, so minus 5 over 11. Plus 2 times x3, which is 9 over 22. And this is equal to 2. So that means x1 plus 5 over 11 plus 9 over 11 equal to 2. So 2 can go into 22 as 11. So this will give us 2 minus 5 plus 9 is actually 14. So minus 14 over 11. So this gives us 22 minus 14 over 11, which is 8 over 11, right? So therefore, you'll have a solution set x1, x2, x3 as so let's do it this way, as 8 over 11 minus 5 over 11 as well as 9 over 22. So that solves this problem, okay? And that's how you use early decomposition to solve this problem, okay? I hope you were able to understand each part of this video. It's something that we've done already in a previous video, so just go through it, solve more problems to get yourself acquainted with this method. And if you have not subscribed to this channel, make sure you do subscribe and then like this video to allow other students like you to benefit from these videos. And the playlist is given down below in the comment section. So make sure that, it's a link in the description, so you could go to the playlist and watch the other videos, other similar videos for this particular playlist, which is numerical methods. And then I'll see you guys in the next video.